Welcome to the lecture series on vitamins and nutrition. So we saw in the previous class about various types of vitamins and their role in bioavailability, and now we are going to look at some of the concepts and extend this idea of bioavailability. So I would like you to recollect this particular slide where the physical property of vitamins play an essential role in the availability of these vitamins for bodily need. So we saw in the previous session that vitamins can be categorized into water soluble and fat soluble, and their property would really play an important role in terms of these vitamins being available for absorption and end of the day and ultimately being available for their role in metabolism. Now we are going to look at some of the processes of bioavailability. So if you look at this slide, you have this concept of precursor vitamin getting converted into an active vitamin. We have seen this elaborately in the previous session. Now I would like to draw your attention to some of the preparations which are basically considered as a poor source for bioavailability, and some of them which can be considered as a very good source for bioavailability. So it's the same vitamin, but the form or the formulation in which these vitamins are available could tremendously contribute in the amount of these substances available for use. Say for example, most of these substances which are prepared in a raw form or in a fermented form or in a cooked form. So you could ask this question, so which form would be like really would be made available for bioavailability related properties? See for example, if you are going to consider vegetables taken in the raw form, the minerals and vitamins are preserved because any kind of cooking would alter the physicochemical properties of the vitamins, and there could be some amount of the vitamins losing their chemical nature. So this is a problem. But when you are considering bioavailability, exclusively we should consider the vitamin. It is available in its rich form, but finding a difficult time getting across the intestinal barrier. So I want you to be aware that if there is any problem connected with the processing, should not be associated with bioavailability. So bioavailability is basically a problem connected with physiology, especially in the concepts of absorption of the vitamin across the gastrointestinal tract. So I want you to be very much familiar with this difference of bioavailability is concerned more into the aspects of absorption across the gastrointestinal tract, whereas if you are going to lose the functional vitamins in the processing of food material, then it becomes totally a different issue altogether. So that would be dealt under food processing, and now we are basically preserving the chemical nature of the vitamins intact, and we would be looking at those aspects towards the end of the sessions, when we are going to look into how food processing plays a role in preserving the nature of vitamins. Now for today's session, I want you to be aware of the certain concepts concerned with how this particular vitamin would be made available for absorption. So there are some nuances connected with how these vitamins can be like really made available in an effective way. So if you look at it, say for example in this slide, the fat soluble vitamins are generally less bioavailable than water soluble vitamins. So this is a fact. So if at all the food material or the food preparation, if it's been aimed in delivering certain types of vitamins, we have to definitely take into consideration this fact. Since fundamentally in the basal level, fat soluble vitamins are less bioavailable because of the physicochemical property, because they are lipid soluble, we have to take certain precautions. As I've told you earlier in the previous session, one good suggestion would be to emulsify them and make them available for absorption. So that's one important point that we need to consider. Second thing is that what would be the source? Say, look here, vitamins from plant foods are generally less bioavailable than those in animal foods. So what could be the reason for it? If you consider plant foods, you have wide variety of cellulose and other complex carbohydrates which could act like a kind of a barrier in making the vitamins available for absorption. So that's one of the reason. In case with vegetable foods, we need to take extra care in breaking down these complex carbohydrates to release the vitamins. But there is again a problem that we need to consider, because the moment we try breaking up complex carbohydrates and the process that we use even during cooking, we are more likely to lose the amount of vitamins that would be available for absorption. So that's the point we need to have, and if at all we find the substances are being lost, then an extra precaution needs to be done. So that's one of the reasons whenever we do a large scale industrial processing of food, the processing in itself will be a negative point in bringing down the bioavailability of vitamins. So to compensate for that loss, normally the industry would sort in adding an extra dose of vitamin after due analytical methods to estimate the exact amount of vitamin being required to enrich the processed food. Now if you look at this, I go back to the concept of absorption, where the fat soluble vitamins stored after absorbed. So you see exactly how these fat soluble vitamins find their way into systemic circulation. So before we look into this, I want you to be aware of one particular concept, what we call it like it's an additional advantage for fat soluble vitamins. In fact, we use this concept in pharmaceutical industry as a type of a special formulation, what we call it like depot formulation. So what do you mean by that? Although we have this problem that fat soluble vitamins have poor bioavailability, but the moment you could make them available or cross the barrier, they stay long, they stay in the adipose tissues, and there could be this fact of slow release. So you could create a kind of a profile where slowly the substances can be released. So all this put together come under the concept of ADME, and that's what we are heading to: absorption, distribution, metabolism and elimination. So ADME concept for vitamins. So how these vitamins go in a very systematic manner across these steps. So what we consider as absorption, distribution, metabolism and elimination. So if you could go back to this particular slide, so this is actually the concise way of presenting the ADME concept. So we go back and you look over here, certain terminologies, what we call it like chylomicrons, lymph, bloodstream. So you see there the proteins which are being attached to the lipid vitamins which have been attached to proteins in the foods, released in the stomach, then absorbed in the duodenum and packaged in the chylomicrons, and finally finding its way in the bloodstream. This is quite interesting. So what exactly happens? You know, proteins are hydrophilic in nature. So since fat is hydrophobic in nature, you could expect the protein forming a kind of a coat or a cover, a very close interaction for the lipid. In other words, what we have, something like a kind of a lipoprotein combination happens. It's not a kind of a chemical entity, although it is possible. Lipoproteins are available, but fat could be covered with a protein layer. That's what we mean by getting attached to protein. It could be covalent attachment or it could be a non-covalent interaction. In any case, proteins which are hydrophilic in nature would bring down the surface tension and thereby increase the absorption of fat soluble vitamins. So once this is done, they could easily cross the duodenal barrier, because duodenal barrier is a checkpoint and would readily permit water soluble substances, and the moment it goes inside, you have the, I would say, emulsified fat soluble vitamins present along with lipid particles, and the lipid particles are categorized depending on the size. So chylomicron, so chylo refers to fat, okay, it's a Latin word which you say chyle. Chyle is like lipid rich substances, so micron refers to the size. So chylomicron is tiny lipid globules in the size or in the dimensions of micron. So you find this fat soluble vitamins finding their way inside the chylomicrons. So chylomicrons are tiny enough for quick transportation, and the lymph, which is basically the fluid, which is I would say all the extra I would say the fluids present between the tissues, what we call it like interstitial fluid across the tissues. Once the blood is being delivered even to the point of fine capillaries, and between the tissues these fluids get accumulated, and there is a separate circulatory based movement for lymph vessels. The lymphatic vessels fundamentally do not have, I would say, the pumping organ heart to maintain that the movement. So lymph flow probably happens by squeezing off the muscles which surround them, and also being promoted through the movement, physical movements and the gravitational movement. So lymph drainage is very essential, and lymph is extremely essential in the transportation of fat. In fact, you know, if there is any kind of mechanism by which you could effectively improve fat absorption across lymph or decrease fat absorption across lymph, could be extremely useful in the treatment of obesity. But that's all about how lipid metabolism happens. But our concern is, since fat soluble vitamins co-migrate along with lipids, we have to definitely consider the possibilities by which how lipid metabolism and absorption happens, and through that way you could essentially also make these fat soluble vitamins available for absorption. So you see over there, so this is how it goes. So if you are not taking, if people are not taking fat rich diet, I mean to say the diet of fat that could give rise to lipid molecules in the range of chylomicrons, okay, the fat soluble vitamins will not be available for absorption. So suppose, let's say a person is on a diet of, I would say, a bland diet without much fat or lipids, the probability that the person would suffer from deficiency of fat soluble vitamins over a period of time is high, is of high stake. And that's one of the reason in all our traditional foods emphasize the use of ghee, butter and clarified butter for as part of your normal routine. So taking clarified butter or ghee would improve the absorption of fat soluble vitamins. So that's the point what we are bringing over here. So in a balanced diet, all this would really contribute in increasing or improving the bioavailability of fat soluble vitamins. So you will never find a child or people malnourished with problems of fat soluble vitamin deficiency if they are on a regular diet taking adequate amount of clarified food, clarified butter in their food. So lack of fat can lead to deficiency. This is very interesting. See, you might wonder, on one side we consider taking excess of fat as could lead to obesity, but what I'm trying to pinpoint over here, it's not like gulping us with so much of fat, but supplementing the diet with minimal amount of fat would really ensure proper absorption of fat soluble vitamins. So you see there, now the fat soluble vitamins goes inside your systemic circulation. So where these fat soluble vitamins are stored, so you see over there, liver is one of the primary sources for storing fat soluble vitamins, especially vitamin A, and to a lesser extent we have vitamin K and E which are being stored over there. But if you look at vitamin D, the storage for vitamin D would be there in the adipose tissues. So when you say stored in the fat, when we use this word fat, don't consider it's the typical fat, it's basically an adipose tissue. So what is an adipose tissue? An adipose tissue is a connective tissue which has been which is specialized in storing fat. So fat is an extremely good source of energy, and adipose tissue are specialized in storing fat that could be utilized for a wide variety of functions in our body. So don't mean to consider that fat is bad, because fat is an essential storehouse for producing sterols, and sterols are the raw material for most of the steroidal hormones in our body. That's one of the reason. If you look at, women have an high percentage of fat. You know why? Women require an high percentage of fat for two reasons. One, the high percentage of fat would provide a higher calorific value during the times of pregnancy and stress, and they are also essential in contributing to the development of steroidal hormones, gender-based hormones. If at all the amount of fat in a person is going to go below the accepted limit, it's going to result in severe fertility problems. Okay, so you see over there the fat soluble vitamins, the good essential adipose tissues maintained within the limit, all are related. So if we don't have proper reserve of adipose tissues in our body, we would find it extremely difficult even to store these essential fat soluble vitamins in our body. So there are genetic cases where for some reason it's a congenital diseases. When I mean congenital diseases, I'm talking about those diseases that people have right from their birth as part of their hereditary makeup, and this could be a serious issue, especially for congenital diseases which have a problem in maintaining and developing adipose tissues. You find they would find it extremely difficult to store these fat soluble vitamin. So in spite of a dietary intake of required fat soluble vitamin, you find these people malnourished and finding it extremely difficult to utilize the required macronutrients to the optimal level, because their body fundamentally lacks the ability to store fat soluble vitamins. So you see over there, vitamin D is mainly stored in adipose tissues and muscle tissue. So of lately people actually have found a very strong correlation, although this is not a new concept. Vitamin D deficiency leads to asthenia. So this is a technical word which means weakness in the muscle, so overall weakness in your body. So people initially thought weakness in the bones or weakness in the muscle could be a problem connected with calcium deficiency. That's true. Calcium is essential for muscular contraction, but now they have found very strong correlation that it's not only calcium, but you also require adequate vitamin D for calcium to effectively function. So let's say you supplement a person with sufficient amount of calcium, but if they don't have vitamin D to the required level, then still you will end up with problems of paralysis and muscular degenerative conditions, including conditions connected with cartilage and connective tissue formations, eventually leading to inflammatory conditions like arthritis. Okay, so you see that you also have on the negative side, that's the last point, which says that buildup of these fat soluble vitamins in the body. See, there is this classical condition, Eskimos, people who live in the Arctic regions, have an excellent source for polar bear liver. So polar bear liver is a very good source for vitamin A. You find these people suffer from skin diseases, exfoliation, which is exactly the opposite of vitamin deficiency. In other words, it's what we call it like hypervitaminosis. So these people, since they have an access to polar bear liver and vitamin rich fatty blubbers of the seal, they consume a lot and they end up in fatty liver, end up in severe toxicity. So this is the other end. So whatever I have been telling you, on one end as congenital diseases where people find it very less amount of adipose tissue in their body, end up in having problems in making the stored fat soluble vitamin available for metabolism. On the other hand, people who end up storing up more of these fat soluble vitamins go into a state of hypervitaminosis, which could also be dangerous. Okay, so now we look at water soluble vitamins. So water soluble vitamins are not stored after absorption. So this is the catch. So if water soluble vitamins are not stored, you need to have a constant replenishing of water soluble vitamins, which needs to be taken care in the food that we eat and the supplements that we take. See, getting deficiency for fat soluble vitamins is relatively very rare until there's going to be a rapid famine. That's the case with most of the underdeveloped countries in the continent of Africa and even developing countries in certain states, where children or people go malnourished for quite a long period of time. Then they end up depleting all the stored reserves of fat soluble vitamins. But if you are otherwise on an average healthy diet, we don't so easily show deficiency for fat soluble vitamins. We do have cases of vitamin D deficiency, because if we don't go around, the natural source of sunlight providing vitamin D would be at stake, and if you're going to have a dietary supplement of vitamin D through vegetable sources, you don't have an issue. But that's not the case for water soluble vitamins. So you see over there, water soluble vitamins relatively find their way into bloodstream quickly because they are hydrophilic in nature, and most of them are absorbed in the duodenum and the jejunum, the small intestine. And since they are not stored, they are readily excreted in the urine. So you could do this test. Take a little bit of riboflavin or folic acid, which are highly pigmented vitamins. So you find within half an hour you would excrete dark colored yellowish urine. So this is a clear example of how a water soluble vitamin quickly finding its way into systemic circulation and then being eliminated instantly as it's been taken inside. So this is actually a good thing in a way. You have an indication. Bad thing, because since we cannot store it, you constantly need to replenish yourself with B vitamins. So that's one of the reason, if you are not taking water soluble vitamins, B vitamins, for a considerable period of time, even with a short notice of a week's period, you find severe deficiency diseases coming up. So that's one of the reason always most of the foods need to take care of how you fortify them with B vitamins. Okay, so you need to have considerable daily supplement of B vitamins and taken in a proper quantity of RDA, daily requirement level, and you avoid all those side effects. Now you look at this. So this is a quick recap of what I've been telling you, the fat soluble vitamins and the water soluble vitamins. This picture gives you, see the fat soluble vitamin being converted into micelles, okay, being coated with protein, improving their bioavailability, and once it goes inside, being packed as a chylomicron, and as chylomicrons they find their way in the lymph fluid. So you see over here the lymphatic system. So that's why we say lacteal. So you would have even studied in your lower classes. So lacteal, which is like milky appearance of the small intestine layer, because fat is emulsified, it gives you a milky appearance. You know, milk, basically the fat being emulsified gives you that white emulsified appearance. So same thing you see over there in the lymph fluid, which basically absorbs all the fat soluble vitamins along with the lipid and appears milky white in color when the absorption takes place. On the other end, you find water soluble vitamins being taken up directly by the portal vein. So portal circulation means all this would be routed to liver and would be partially metabolized over there, and then the one which doesn't go to liver, which goes into systemic circulation, is alone available for metabolic role to play. So you always end up some amount of substances being metabolized in the liver. You may ask why we have this arrangement in our physiology, why we need to have some amount of substances that needs to be degraded in the liver. It's actually for good, because liver takes up the role of metabolism. There could be lot of exogenous xenobiotic substances that might find its way into our systemic circulation. So if you do not have this mechanism of first pass metabolism, we would eventually end up having our system dumped with wide variety of xenobiotic substances, and also you need to be aware that these substances on a kind of a cumulative basis can become extremely hazardous. So first pass metabolism is a natural biochemical metabolic checkpoint to prevent xenobiotic substances getting accumulated in our system, and liver really would do that job. But on the negative note, since it's a positive checkpoint, screening everything, even the routine food substances and the vitamins present in the food substances undergoes this check, and obviously you lose some amount of substance. So instead of like cribbing about this first pass metabolism, we should find ways how you can improve bioavailability of these substances and thereby improve the quality of the nutritive value of the food that we consume. So this picture is a very interesting picture because this picture gives you how we are going to do evaluation of bioavailability, because until you really do the study, so you might wonder, so much of discussion we had about bioavailability and making the substance available for circulation, so how we really know that this thing could be done. So what we do, people have done a lot of study, not only in human beings. To start with, all the studies are being done with animal models to establish bioavailability, and obviously the concept could be extended even for human beings. So here you find a plot. So the concentration curve versus the time. So this is a plot of concentration of the substances versus time. So what do? You take a substance, let's say a predetermined concentration of a vitamin, you allow the substance, probably consume them through an oral route, and then with the pre-planned time interval you collect blood samples, okay, for every time interval, and plot the concentration of these vitamins. So as you plot the concentration, you get a curve like this, what we call it like area under the curve, or you call it like the absorption plot. So you see over there, there is a steady increase and it peaks up, and then there is a steady decrease. So it means what? Initially the concentration is quite high and absorption steadily increases very well. A point comes, then you reach a stationary phase, then eventually the amount of substances being metabolized is greater than the amount of substance getting absorbed. In the initial phase, the amount of substance getting absorbed is greater than the amount of substance getting metabolized. You find a constant increase in the concentration, and eventually you find the curve tapering down. So this is what we call it like the area under the curve. So you see over here, from this you decide how long it takes for us to reach a maximum concentration of vitamin, and if you could extend this area under the curve, you could extend the time period in which this substance is made available in circulation, you probably extend the amount of substance, especially in our case the vitamin available for metabolism. So we would continue more on the bioavailability evaluation of individual vitamins in the coming sessions. So I'll do a quick recap of today's session, and we started with bioavailability, and I explained in detail about carrying over the concept what we had done in the earlier class on provitamins getting into the active form. Then I dealt elaborately on the absorption principles, how fat soluble and water soluble vitamins getting absorbed. Then we also did what could be the limitations of fat soluble vitamin and how you can improve upon that. Then we also saw what are the advantages that we have with the storage adipose tissue, and the disadvantage what we face with fat soluble vitamins where we lack a definite storage system and how it can be improved. And finally we had a brief intro to the way by which we can evaluate bioavailability. So I think it was useful for you, and we'll continue more on in the future sessions dealing more on bioavailability and concepts of vitamins. Thank you.